Hi students, this is Mr. Yao. In this lesson, we're going to review triangle congruence and learn how to do proofs with triangle congruence. So first, let's review what are congruent figures. Congruent polygons have congruent corresponding parts, which means they have their matching size and angles. So when we name congruent polygons, we must list corresponding vertices in the same order. So as you can see the shapes on the right side, A, B, C, D, that means they're corresponding with each other. So A is corresponding with E, B is with F, and then C is with G, and D is with H. So these shapes are actually corresponding with each other. Now let's have a look at example 1 to actually see how we write the corresponding parts. So for these two figures, what are the corresponding parts? If you look at the shape, well, if you look at the given, H is with L, I is with M, J is with N, K is with O. Whichever letter is in the corresponding position for each shape, that means they're corresponding. So first we have size. HI, that's the first two letters in the first shape. Then, of course, LM, the first two letters in the second shape. That's why they're corresponding. Same thing with I, J, and then MN. JK is congruent with NO. KH is congruent with OL. Doesn't mean you have to write them exactly in this order. So, for example, if I want to call this HK, I totally can. Then that means I'm keeping the first letter and the last letter in the first shape. Then I just need to do the same thing with the second one. So I can do L, because L is the first letter in the second shape and O is the last letter. So I can also do that as long as they're in the corresponding position. And then we also have corresponding angles. H and L, they are corresponding, the first letter, second letter, I and M, third letter J and N, last letter K and O. And in this case, you can see we're using one letter to represent all the angles. If, let's say, this is our shape, we just have some extra line. Let's say that is the case. That is the case, then we cannot, for example, call this angle K, because at this point K, we have 1, 2, we actually have 3 angles. In that case, we need to be very specific. We can say angle HKJ is corresponding with angle. That is going to be L, O, N. Okay, so we just need to be very clear on which angle we're naming. And in that case, HKJ was the old K, because we also have these two other angles, HKI and then IKJ. Just need to be very specific. Okay, that's example 1. Next, example 2. Are the triangles congruent? So in this case, we can see we have, well, right now we don't, we're not talking about all these special ways to actually prove triangle congruence. We're just using the definition. That means all the corresponding sides need to be the same and all the corresponding angles need to be the same. So we're basically looking for 3 sides and 3 angles. So clearly that one is being labeled, so they're the same. And the 6, they're the same. And the 4, they're the same. All the 3 sides are corresponding. AB is congruent with E, then BC is congruent with BC, then we also have AC is congruent with EC. So we can see the 3 sides are easy to identify. Next, we're going to look at angles. We can see angle A, they're having this single mark, so angle A is congruent with angle. We also have this double mark right here, angle B is congruent with angle C. Last one, we just have one more pair of angles, and these two, we can clearly see they are vertical angles. But be careful when you name them, they're not just angle C, because there are 4 angles around angle C. So I have to be very specific. Angle BCA is congruent with angle DCE. And we can see there are 3 pairs of sides that are congruent and 3 pairs of angles that are congruent. So yes, they are congruent. That is example 2. Next, example 3. which is something we actually know already. The measure of the interior angle of a triangle add up to 180 degrees. Now let's actually try to prove that. That is something we have been using all the time, but we never proved it. So first step, we're going to draw a parallel line. We're going to draw BD. And didn't say we need to label this point D, but it's just a point on the line we're going to draw. BD is parallel with AC, so we just draw that line. And that is by parallel definition. Next, let's label some angles. I'm going to call this angle 1, that's 2, that's 3, that's 4, and that's 5. So that's easier to actually name. So we can clearly see angle 4 and angle 2 and angle 5, they add up to 180 degrees. That is because these are three smaller angles, they add up to make this bigger angle. So angle addition postulate, and that is also the definition of straight angle. Because we're having a straight line, so that is straight angle. Next, we can see angle A and angle 4, they are congruent. Right here, angle A, which is angle 1 as well, and angle 4, that is by, I'm going to extend this line so that you can see clearly. That is alternate interior angle, and we have the other one as well, the 5 and C, that is the other alternate interior angle. So that is alternate interior angle theorem. Next, because they're congruent, we can say angle A, the measurement angle A is the same as angle 4. The measurement angle C is the same as the measurement of angle 5. So that is congruence. After that, we can see angle 4, we can replace that with angle A. Angle 5, we can replace that with angle C. And angle 2 is basically angle B. So we can say angle A plus angle B plus angle C, their measurements adds up to 180. And that is substitution property of equality. So we're just replacing things. And now we have proved all three angles inside the triangle adds up to 180 degrees. Next question, do you need to prove all corresponding angles and sides are congruent to prove two triangles are congruent? That's basically saying, do you actually need all three pairs of sides and all three pairs of angles to actually prove? The answer is no. If we have enough information, we can just use what we have. And now comes all the triangle congruence theorems. First one, CPCTC. Corresponding parts of congruent triangles are congruent. That one is the one we can actually use the abbreviation, and that is totally fine, CPCTC. Basically saying if two triangles are congruent, all their corresponding parts are congruent, which is what we actually used at the beginning. And here are all the triangle congruence postulates and theorems. And we can only use these given five: SSS, SAS, HL, ASA, AAS. These are the ones. Now let's have a look at how we can use these to justify if two triangles are congruent or not. For all of these examples, decide if each pair of triangles are congruent. If yes, fill in the congruent statement. We're also going to talk about the reasons why they're congruent or not. So for the first one, we can see they're being labeled and BD is being shared. And we can see these two angles. So that is side, angle, side. So yes, they are congruent. The reason is side, angle, side. The statement is triangle ABD is congruent with triangle CBD. Next, congruence or not. We see one pair of lines, we see another pair of lines, but there's nothing extra, no extra pair of lines, no extra angle. That means is SS, and we don't have such a thing for triangle congruence. The answer is no. Number 3, we can see that is side, and the next thing is actually another side, then we have an angle. So we have side, angle. Is that actually for congruence? It's not given in the 5, so that means it's not. But let's see if we can think of a counter example that is also side, angle. So for example, let's say this is our shape. our first triangle. And this is our first triangle. Now I'm going to draw a second triangle. Of course, coinciding the lines, then we have that. Okay, and I can say these two are the same. You can see they share this line right there, and they also share this angle, but there's another opposing side, so that basically is side angle, and that clearly are not congruent. So that means we can make two sides that are actually the same length, but tilted to different angles. So that is not. Number 4, we have one pair of lines, two pair of lines, and three pair of lines. So that's S, which is, yes, the triangle TUS is congruent with, you can see T is between the 1 bar and the 2 bar. 1 bar and 2 bar in that case is X. So triangle X. Then U is between 1 and 3 bars. So next we're going to WV. Make sure you actually have them corresponding. But that's not the only way to write it. You can also write it as, say, UST is congruent with WVX. That's fine too. You just need to make sure the points are corresponding. That's number 4. Next, number 5. You can see there's that, and there is a right triangle. They also both have this line. So that's the hypotenuse, and this is the leg. So it's the reason HL. And that is the special one for a right triangle. So yes, they are congruent. The statement is triangle YAZ is congruent with triangle YBZ. Next, number 6. Yes, we have a right angle, but the hypotenuse is not being labeled as the same. So again, it's not that whenever you see a right triangle, it's HL. It's not. In this case, we have one pair of sides, another pair of sides, angle in between, so it's side, angle, side. Yes. Triangle CDE is congruent with triangle FGH. Next, number 7. You can see they share the MK, and they also have another 2 pairs, so S. Yes. Triangle JMK is congruent with triangle L. Remember, even though MK is the line that they actually share, but from J is going on to M on this 2 bar. From L, we need to use the 2 bar, so it's actually going to KM. That's how they're corresponding. It doesn't mean they have to be in the same order. Number 8, that looks like it's angle. But angle is not a thing we use to actually prove for triangle congruence. The answer is no. And here's a counter example. I can just make it bigger. Draw all parallel lines. I can make it bigger. They have the same angle, but they're not the same. They're not congruent triangles. So number 8 is no, because we don't have such a thing that's AAA. Now let's look at some proofs. Example 1. WZ and XY, they are perpendicular, and we have a given pair of angles that are congruent. We're trying to prove the sides are congruent, WX and WY. Whenever you see these triangles, and you see we have some given information, a pair of angles, another pair of angles, we have this shared side, we know we're trying to prove the triangles being congruent, the parts are going to be congruent. So that's kind of the logic behind it. And you can see the first step is they are perpendicular. That is given. And because they're perpendicular, that is the definition of perpendicular. So we can say they are right angles. And this next is something that should make sense, but we have never talked about it. It's called right angle congruence. It's basically saying all the right angles, they are congruent. That's what it is. That's right angle congruence 0. Next one is given again. Because, well, and the next one, number 5, that is reflexive property, because basically is something is congruent to itself. That's reflexive property. And because we have angle, and the side in between, that is angle, side, angle congruence. And because the two triangles are congruent, that their corresponding parts, the WX and the WY, they are congruent, and that is by CPCTC. And that is example 1. Next, example 2. We're going to have a very similar proof right there. X is the midpoint of VW. So this is the midpoint. And UX is perpendicular to VW. So this is 90 degrees. It's asking to prove these two are the same. So we basically know, oh, these are midpoints. So these two are the same. And they share this line right there. And we have a 90-degree angle right there. So again, we're going to use triangle congruence to try to prove these two angles are the same. So first, midpoint, that is given. Because it's a midpoint, we can say Vx is the same as Wx. That is the definition of midpoint. Next, perpendicular, that is also given. And you see from perpendicular, we're going to go to right angle, and then we're going to go to the angles being congruent. That is kind of a process, a pretty typical proof procedure. So definition perpendicular, so we can say from perpendicular, we got right angles. And then because they're right angles, we can say they're all the same. And that is by right angle congruence theorem. And the next one, saying something equal itself, that is reflexive property. And now we have side, I'm going to circle them for you. We have side, angle in between, we have another side. So next, side, angle, side, congruence. Because the triangles are congruent, we can say their corresponding part, which is this middle letter B and the W, the angles are congruent. That is by CP/CTC. That is example 2. Next, example 3. Angle N is congruent with angle S. That is given. And next, angle NQT, which is right here, is congruent with angle SQR right there. We can clearly see they are vertical angles. And that is vertical angle congruence theorem, or you can just call it vertical angle theorem without the word congruence. That is fine. Next, you can see that it is given. After that, it says definition of bisect. When something is bisect, from definition, we're just getting two parts that are the same. So TQ right there is the same as RQ right there. After that, if we have a look, we have angle, angle, side. We have angle, angle, side. And that is actually in the one of the 5 theorems that we can use for triangle congruence. So angle, angle, side, congruence. That is example 3. Next, example 4. We're given that. And if you have a look, PM is perpendicular, that's given. AM is congruent with BM. We know that. We're trying to prove AP is congruent with BP. That's what we're trying to prove. And if you have a look, we share this one side, we have this angle, we have another side. So that means we know we use the triangles to actually prove. And this is the perpendicular bisector theorem, because this line PM is basically the perpendicular bisector. So AM is BM, that's bisecting, then we form 90 degree, so that is perpendicular bisector. Perpendicular bisector theorem said any point on this perpendicular bisector line is equidistant to the endpoints, in this case the AM. So first, that is given, and then because of that, again, perpendicular, right angle, and then congruent. That is the process. Given the definition of perpendicular, the right angle congruence theorem. After that, we have another given, and PM itself, they're the same. That is reflexive property. And because of that, now we can say we have this angle, we have the side, we have another side. And if you look at it, that's side, angle, side. So side, angle, side congruence. And because the triangles are congruent, we can say the parts of a triangle are actually congruent. So CP/CTC, corresponding parts of a triangle of a congruent triangles are congruent. Now we have one more, last example. Angle 1 is congruent with angle 2, angle 3 is congruent with angle 3, angle 3 is congruent with angle 4, BCE is congruent with DCE. you can see that is actually using a smaller triangle. And from what we see, we can only see, oh, there's this line right there. We don't know anything else besides the angle. So we don't have enough information. That means we do need to use the 2, 4, 1, 3. So we have to use the bigger angle, ADC and AD, to actually prove, so that we can have more information. So my first step is going to be angle 1 congruent with angle 2, angle 3 with angle 4. Given. And then we can see AC is congruent with AC. That is reflexive property. Because of that, angle side angle, we can say triangle ADC congruent with triangle ABC EPC. Well, sorry, not that. That's the next step. Because the triangles are congruent, well, because the angles are congruent and the one side, that is angle side angle congruence. Because of that, next step, we can get CD is congruent with CB. That is CPCTC. And now you see we have these two parts being the same, and they share this middle line. We also have angle 1 and angle 2 are congruent. So next, I'm going to say angle 1 is congruent with angle 2, and that is given. I'm just going to list it again so it's clear. We can see CE is congruent with CE. That is reflexive again. And next, we have side, angle, side. So lastly, we can say triangle BCE is congruent with triangle DCE, side, angle, side, congruence. And that is example 5. Now we're done with everything for this lesson. Thank you.